Okay, next up we're going to throw in algebra into what we're doing. Right now that's all just order of operations. That's like pre-algebra type stuff. You've probably seen it before. You probably practiced it a bunch. I'm just asking you to get better at it. What's going to happen now is we're going to talk about evaluating algebraic, algebraic expressions. And the big thing here is plugging in the value of the variable. Sometimes you know it, sometimes it's given to you, sometimes you're supposed to figure it out. That's what we call solving equations. But right now, it's either going to be given to you or you're going to know it already for some reason. Sometimes there's just one value, sometimes there's many values. The biggest hint I can give you here, what happened to this? There we go. The biggest hint is this part right here. When you substitute those variable values in, do it with parentheses. This is the common mistake I see. I'm going to do this in red here. I see x equals 2, and I'm trying to evaluate 5x. Well, 5x means 5 times x. And if x equals 2, this means 5 times 2, which is 10. But I have seen students say, oh, it's 5x, and they plug the 2 in there, and now they write their answer down to 52. Totally forgetting that when these two things are next to each other, the 5 and the x, it means multiply. I warned about that in the last video. We use the one that's most convenient, but it also might cause confusion for someone else. So 52 is definitely not the answer. My tip, particularly on bigger expressions, is to rewrite the expression, but wherever where that variable is, put a set of blank parentheses first. And then take the value that you're supposed to plug in, 2, and plug it in. And now you have preserved the idea that it's multiplication, and that they are two separate numbers. And you end up with the correct answer of 10. So, parentheses help make substitution work a little bit better. Let's look at example 4 here. We're going to evaluate an algebraic expression. So, we have 3x squared, and it's always a good habit to get into rewriting the problems down. You don't have to rewrite them completely down, word for word, but the expressions you should write down. Like I have mine right next to each other, but yours is in a book and then go into your piece of paper. That moment of translation, if you try to do it in your head on the first step, it can cause errors. Even just copying exactly down what you see, sometimes errors pop in. And I've had plenty of students, even in my Algebra 2 class, miss problems because they didn't copy it down correctly. But it's usually easy to figure out what's going on then. Say, oh, you just forgot the cubed, you put a squared instead. For some random reason, that's what their brain thought. So any one of those things works just fine. I've got my different values here. X equals 4, Y equals 5, and in blue I'll do Z equals 3. If you notice here for my Z's, I do a Z symbol, but I put a little bit of bar in it. It's because sometimes they end up looking like my 2's, so I don't want you to confuse them. If you see that little bar, that means I've got a Z there. So I've color-coded them, which is nice, and if you like that kind of stuff, get yourself a box of colored pencils and use that whenever you're substituting in. Now, I'm going to substitute all these values in. 3 times x squared, notice I'm just putting parentheses, plus parentheses 2 times y, plus z cubed, and I'm going to close that off with parentheses. Now, I'm going to look through the original expression. Anywhere where I see an x, I'm going to write down the value of 4 because that's what x equals. Here I have 3x squared, so I should have 3 times 4 squared. 2 times y, and y is 5, so I should have 2 times 5. And in blue, z cubed, z is 3, so I should have 3 cubed. So that's the idea there of the color coding it, to really make sure it's clear which numbers go in which space, because sometimes you'll have multiple of the same variables, and you got to keep track of that somehow. But now when I get to this problem right here, 3 times 4 squared plus 2 times 5 plus 3 to the third is no different than any of the last examples that we did. We've gotten rid of all the variables. Now it's just an order of operations problem. And just like I was saying in the last video, when you get to the more complex problem, we've just added one little bit each time. Just add one little bit. Make it just a little bit more complex on them. So, I'm going to make this a little bit faster by starting to combine some of the steps together, because hopefully you might still be practicing doing one step at a time, but to make these videos shorter, I'm going to combine some steps together. I'm going to take care of all the stuff inside the parentheses, multiplication and powers. So I have, I'll draw a little arrow up here, 3 times 4 squared plus everything inside these parentheses. 2 times 5 is 10. 3 to the third power is 3 times 3, 9, times 3 again is 27. So that's simplified out there. And now I'm going to go 4 squared is 16. So I have 3 times 16 plus 10 plus 27. Well, 10 plus 27, that is 37. 3 times 16, you might need to do this one off on the side. 3 times 16. 3 times 6 is 18, carry the 1. 3 plus 1 is 4, that's 48. And now I just have to add those two together. 48, well, 40 plus 30 is 70. 8 plus 7 is 15. 70 plus 15 is 85. So there is my answer. If you wanted to do that old school, you could have done it old school. 7 plus 8 is 15. 3 plus 4 is 7, plus another 1 there is 8. And you'd see it's also 85. Alright. That's one of the most complex versions of what you're going to be doing for this section of the book. I'm going to pause it and then we'll do the last example or two.